For this video, I'll be going over my first quotient rule example. I did c of x divided by a of x. For my problem set, I had sine of x is equal to c of x and cosecant of x is equal to a of x. Using this, my equation for my first problem is h of x is equal to sine of x divided by cosecant of x. Using some trig identities, I turn this into terms of sine and cosine, which means that my equation, h of x, is equal to sine x over 1 over sine x, because cosecant of x is equal to 1 over sine x. Although I could simplify it from here, I'm going to use the quotient rule anyways, because that's what it's just about. So I first defined the numerator and the denominator in terms of f of x and g of x, so that way I could put it into the quotient rule. The numerator is sine of x, so I made that f of x just, because I decided to. So f of x is equal to sine of x. F prime of x, or the derivative of sine of x, is equal to cosine of x. It's one of the trig rules. We've gone over it a couple times. The denominator was a little bit more tricky because I had a complex trig, just because it was just like a couple different terms. So it's g of x is equal to cosecant of x, which I turned into 1 over sine x. But g prime x is equal to negative cosecant x times cotangent x. I got this from the trig identities packet we got a little while ago. I didn't actually solve that out myself, I'll be honest. But I did have to turn this into terms of sine and cosine. So I did that by knowing that cosecant of x is equal to 1 over sine x, and cotangent x is equal to cosine x over sine x. So these are being multiplied together, and cosine x is negative, so I have a negative 1 over sine x times positive cosine x over sine x. So you have negative 1 times cosine and sine times sine, which gets us negative cosine x over sine squared x as our derivative of the bottom, which is g prime x. So using f of x and f prime x and g of x and g prime x, I can actually plug it into the quotient rule equation that we have right here. I have it written out in the order that I actually plugged everything in, because sometimes I switch it up. But the first is g of x, which is 1 over sine x, so I have it right here, and then f prime x, which is equal to cosine x, because it's the derivative of the top. So I have 1 over sine x times cosine x over 1. I'm going to end up multiplying across. I put cosine over 1 just to simplify it here in this step, because you're going to have cosine times 1 and sine times 1, which turns it into cosine x over sine x. So that'll be on the next step. But then the next one is subtracting g prime x times f of x. So g prime x is this whole long thing that I solved for, which is the negative cosine x over sine squared x. And then that's multiplied by f of x, which is just sine x. So I put sine x over 1 again, so that way I could multiply across. You'd have the 1 multiplied by the denominator, keeping it the same, and then sine x times cosine x. Then on the bottom, you have g of x squared. So I have 1 over sine x, or 1 over sine x right here, and I have it here squared. I'll simplify that later. Usually I don't do anything with the denominator until I need to. So this is it simplified for now. As you can see, I multiplied across because I had like the 1 over sine x and the cosine x over 1. So I multiplied that across and just got cosine x over sine x. Then in this step, I'm multiplying across, so I have my negative cosine x times sine x and sine x squared times 1. So this is going to remain the same. This is going to turn into negative cosine x times sine x. But we have this negative in the parentheses and a negative outside. So you have a negative 1 times a negative, which is going to turn it into a positive when you add these together. So it's going to be a positive in the end. So now if you see, I've combined that step. So it's cosine x over sine x plus cosine x times sine x over sine x squared. And that's all over the g of x squared, which is the denominator squared. I'm going to end up distributing this squared to the sine x. 1 squared is just 1, so it's just going to be the denominator that's squared. But I think that happens in the next step. But here what I want to do now is to create a common denominator so I can add So I have sine x here and sine squared x here. So if I just multiply this one by sine x over sine x, then they'll have the same denominator and I can just add across. So here I'm actually doing that. I have cosine x times sine x and sine x times sine x plus cosine x times sine x over sine x squared. And then that's all over 1 over sine squared x. It's all pretty simple. Now these two terms are actually identical once you distribute out. So you have like two of the same thing. If you look here, you have cosine x times sine x plus cosine x times sine x over sine squared x over 1 over sine squared x. This is why it looks so simple at the beginning. So it's going to end up being 2 cosine x sine x, because you have 2 right here. You can combine the terms. Then since this is 1 over sine x, I'm going to multiply by the reciprocal so I can get rid of it, because we have it right here. We can just get rid of it. So I have sine x squared times sine x squared over 1. So I'm going to multiply this by the top, and I'm going to end up dividing out, as you see here. So now I have sine x squared times 2 cosine x sine x over sine x squared. So I can actually cross these out. They're gone. Now you just have a denominator of 1, since the sine squared x divided out. It was on the numerator. It was being multiplied by the numerator and being divided by from the denominator. So it was just canceling itself out. So now the denominator is just 1. It's 2 cosine x sine x over 1, which is just 2 cosine x sine x. So that's your derivative. I think you can use some trig rules with the half and double signs, but I don't know if I needed to go that far since we're not doing double half angles anymore. So I just left it here. I felt like that was good enough. But yep, that's my answer.